Lord, remembered today. 2 days in a row. This is incredible. All right, so welcome everybody to class. All four of you, according to Streamlabs anyway. It's always fun. Doesn't update for like 5 minutes with the people in the room, so looks like nobody's here to me. 17, hey, there we go. Yeah, I'm seeing, oh, now it's 15. I move it to this screen, it goes 15. Over here, it was 4. All right, good enough. So today we're going to have a very exciting lecture. That's why you got some amazing hype music. I'm not trying to oversell it or anything, but it's pretty exciting. It's going to be all about software engineering. As a reminder, you got homework due tonight, so that's your homework 1. It's your ethics articles and team formation. If you didn't get a team for whatever reason, just note that in your last question, and I'll plop you onto another team early next week. So just make sure you get that in. Don't leave it blank, basically. And if I could get somebody to stop me at 9:40, I want to give you a short little demo on Git. So I bumped your homework 2 part 1 to Friday since I didn't want you to be working over the weekend on this little learn Git branching page. Oh, I searched for it. I thought I went right to it. But again, this is part 1 of your homework assignment. We're going to be using Git and GitHub for our projects and our homework. And I want you all to be aware of what's kind of going on with it. So just make sure you work through that in advance. People tend to have problems with some of the later stages. So just be aware that is floating there for you. We'll look at GitHub a little bit later. Let me pre-zoom that just for fun. But what we're going to talk about now is software engineering finally. So we talked about ethics, right? We talked about the disasters and why we need software engineering. Let's actually talk about what it is today. These slides are from another person. See this nice little new aspect ratio. Basically, this is a very good set of slides for kind of giving you an overview of what software engineering really is and how it's different from computer science. Now, you're going to go into the workforce eventually. Some of you are seniors, some of you are sophomores, wherever you are, eventually you're going to go look for a job. And more or less, the job descriptions will all say software engineer, which is weird because we're training you to be computer scientists, right? Software engineering in industry means that you're going to go out and you're going to work on a project team, you're going to write code, you're going to do everything that goes with writing code. But in this class, we're going to focus on software engineering as kind of the things that surround coding. The interesting thing that you're going to discover with software engineering is that writing code is going to be like a small part of your job once you actually get into it and you're not doing basic grunt work and writing code every single day. It's going to be documentation and meetings and all kinds of things that they never warn you about in school. If you can get an hour or 2 a day to code, you're lucky in a way. Depending on where you work, obviously. It might be different place to place. But just be aware, writing code is not all there is to being a software engineer. There is a lot of overhead that goes with that, and that's how we get good quality code rather than some cruft that you kind of rush out and it breaks 3 weeks down the line. So that's what we're going to be effectively talking about in these slides. It's probably going to boil over to Monday would be my guess as well. I'm going to skip over some of these slides because some of them talk about like Therac and some of those other case studies. We already talked about them at length, so we don't need to talk about them again. I'm sure you're getting bored of that by now. We're also going to look at a little bit of history too, in terms of software engineering. So how has it changed? Obviously, it's 2021 now. It is not 1980 any longer. It is good to kind of go back and look and see how we've evolved as a domain and where we're basically going with that. So, what is software engineering? Great question. We are week 3 in the class now. Week 2. I get lost in days when I don't actually have to go into the office anymore. Week 2. Okay. and we're finally talking about this. Software products are large and complex. So first line read verbatim. Don't do that when you're presenting stuff. Um, but it's a very true statement. When you write any software, it's not going to be hello world. It's going to be a whole lot of moving pieces. It's going to be a whole lot of complexity. And you're going to need to really understand how to break that down into manageable chunks. And that's one of the things we get at with software engineering is making sure that these projects that we, are either assigned or that we buy into, that we can manage them and accomplish them in a given amount of time with a given amount of budget. And you're going to get different perspectives on this. It's going to come at you from project management perspective. It'll be from the developer perspective, from the quality person's perspective. We're going to kind of look at this problem from many different angles. And hopefully as we go, you're going to learn that there's many different types of jobs available to you too in this field of software engineering. Maybe you don't like coding, right? Maybe that's not your thing, but you're really great at finding problems in other people's software. You can go into the quality assurance domain to make sure that what is being created is good and valid and meets requirements. Right? Basically, you're kind of editing other people's work. You're a professional quality assurance person. Tends to be an entire department at companies. So, with these problems that we have, we can basically start by analyzing the problem, and we can kind of come at it from two angles here. So let's say that we get assigned a project. You're going to work for GE, you're going to build a widget on the next airplane that they're working, maybe they're working with Boeing or something like that. And it's going to be some kind of magic flight controller, autonomous. I, I'm not in the auto or aerospace domain, but you have to make components for this airplane, right? You can either start looking at this from a big perspective and look at it top down. Okay, here's this big problem. How do we break it down into manageable pieces? Right? We need code running on this microcontroller. We need this microcontroller to talk to this microcontroller. These devices will all come together, make a decision on course setting. We'll communicate that to the pilot. It'll go up on his little touch screen, and then you have a, working component. So you're taking this big problem and you're breaking it down. Work on communications today, work on implementation today, work on X, Y, and Z today, tomorrow, and so on. So basically, you're getting little tasks. I'm using the word tasks kind of intentionally because that's one of our project management things that we'll be doing is creating tasks. If you're looking at it from the agile perspective, which I'm going to guess some of you, if you've had internships, probably have heard of, might be user stories instead of tasks, but basically you have something to work on, right? You can also look at it from another perspective. We can start small and we can build upwards. So let's say that we know we have all these little pieces to make. How do we bring them all together into one cohesive chunk? So basically what we're kind of getting at here is, are you a top-down or a bottom-up type of developer? Both are fine. It just kind of depends on how you're getting the software specified to you, depending on what your client or your customer is telling you and how your project team works. One thing that's going to become very clear throughout this class is that it's a study of trade-offs and decisions. It's not always going to have a clear-cut answer what way is the best. If you can basically make sure that a problem is going to be solved correctly, doesn't matter how you got there as long as it's done correctly. What are the trade-offs of making these decisions? We're going to be talking about a lot of that as we go along here. So first one, top down, we get a problem. So this is analysis. Problem is this thing to solve. We want you to write a quantum computing bit of software. I just learned there's a Python package for that now. Learn how to do quantum entanglement and teleportation. Okay, that's the problem. How do we break it up into pieces? Find out what Python package you need. Find out what hardware you need to run that. Implement some code. Run it and test it. And then bring all these pieces together into one cohesive package and deliver it to whoever you're working with, right? So take a big problem, break it down into manageable chunks is kind of the takeaway here. You also have the synthesis process. Now let's say that you have a problem to solve and you have 4 solutions and they're all parts of the puzzle. Maybe they all work together. Maybe they're all separate yet valid answers, right? Solution one here is perfect. Solution two was a little bit quicker to develop, but it has a little bit more of a higher memory overhead. Maybe that's a problem in like an embedded system environment. Solution three, very, very tiny bit of software is absolutely great and high performance, but it's targeted to a specific bit of hardware. And then solution four is overly bloated. It's got a million NPM packages, but it works. Which one do we pick? And do we have to kind of compose them together? Again, it's going to be an analysis process, and we're going to have to figure out what's going to work for us here. This is a very abstract way of talking about problems, right? Just which perspective are you taking on it? So a couple of, get that off the screen, a couple of definitions for you. So you're going to be hearing these terms as you go. Methods, tools, procedures, paradigms, these are all great little buzzwords in software engineering. Method is just a procedure that we're going to be using to do something. A tool is something that's going to help us. A tool could be Git. A tool could be Valgrind to check our memory in C. Tool could be JUnit. It just kind of depends on what we need. Procedure is taking those tools, taking those techniques, making a product. Paradigm, this is one that computer scientists love to use. It is a paradigm, or marketing people like to use it too. It's paradigm shifting. This is just for you're following some kind of philosophy or methodology. Like we're going to be object oriented, we're going to be agile, we are going to be insert buzzword here, right? So all these terms really mean it's just going to be how you accomplish your goal at the end of the day. Good so far? Kind of the high level intro to software engineering. All quiet in chat. That's good. That means you've already tuned me out. All right. So where does software engineering fit into your career path here? Again, you're probably computer science or your IS or your IT, whatever your field is, that's fine. It's good to learn kind of this material to really support you as you go. It's honestly relevant to pretty much any computing domain. Computer science is really more of a focus on the theory of computing, right? You're going to learn programming languages, you will learn operating systems, you'll learn all these little points here in this first bullet, but we're not really engineering anything, right? You're learning how to use it, you're learning the theory of it, you're learning everything there is to know about it. But how do we take all of that knowledge and apply it? So, at least to me, software engineering is applied computer science. Take all these things that you have learned to do with a computer, and I'm pointing at my screen like you can look at me here and see what my hands are doing off screen. There we go. We're applied, right? We are taking all these techniques and turning them into real world products that other people can use. So take a look at this figure here. This will help you out as well, maybe a little bit in terms of where software engineering fits in. Computer science over here, you have your theories, you have your functions, you have all of your 4 to 5 year path of CS. Over here, we have a customer. Yep, let's throw our phone on the ground. That's a great idea. All right, just calendar entries buzzing. Phone is blowing up, makes me think there's some kind of emergency happening. So then we have our computer scientists over here. We have a customer, they want something, right? We have a problem, or we have a product that they want to make. Your friend comes to you with an app idea. They can't build it because they're not a computer scientist, but hey, you are, and you're not doing anything, right? They'll just keep 100% of the profits and give you exposure. Anyway, so they have a problem. Software engineering brings together computer science, and it brings together the real world, and actually using what we have learned in CS or IS or IT to solve a problem, right? So we're going to build products, basically, is where we fit in. So good thing to consider is how successful have we been in this domain? Again, applied computer science, basically. We've gotten quite good at computing, right? I've given you all the horror stories so far, things blowing up and people dying, people getting hurt. It's great to motivate in terms of the bad, but there's also a lot of good that we've done too, which is delightful, right? We can do things very, very quickly and effectively. You can pop open your web browser, go to our Google G Suite account. You can do word processing, spreadsheets, email from one single web interface, right? You don't even need Word anymore, or WordPerfect, or LibreOffice, or whatever your favorite word processing software is. You can just go to the cloud and use it, right? So we have office tasks that have been streamlined. Medicine, agriculture, multimedia, pretty much every industry has benefited from good quality software engineering. So we've made a lot of great advancements. And to give you another little thing, and I get a kick out of this, honestly. Where is it at? Bup, bup, bup. So I was reviewing a research paper the other day on quantum computing, and it got me kind of interested to see where we are with quantum because I was following the IBM and Google stories about, quantum supremacy. We're building all these crazy machines, and I'm thinking, well, IBM provides virtual machines to do quantum computing now for researchers. Does Google do that too? And I'm like, oh, okay, Google's got this quantum AI thing. I'm not trying to push Google here, mainly just I was looking at what they had. And then I learned somebody's already made a Python library for quantum computing. We don't even have quantum computing hardware, yet we're emulating it. And we can, oh no, I clicked it. No, Ubuntu, don't do that to me. Ah, every once in a while, Ubuntu and Windows just freezes up on me if I click it too early. But if we, this here, yeah. So here I've got a Python script. I just copied this off of their demos page. Make some quantum circuits. I really have no idea what this is doing because I don't know anything about quantum computing yet. But with our advances in computer science and software engineering, I can run this on my normal everyday computer. It takes a few minutes to run. It's not doing real quantum computing, but it's doing it in theory. And this is kind of where we're at with software engineering. It's honestly incredible. And why is this taking so long to run? It ran very quickly yesterday when I did it. Watch this break my computer now while I'm doing a demo I wasn't planning on doing. All right. This tells me my computer needs to be restarted when things start doing stuff they shouldn't be doing. Okay, so we have problems. Hey, I've got a bug right here. Um, Windows subsystem for Linux, please stop freezing on me when I click you too many times. Okay, so things are good too, right? We also can have issues with our software, and this is where a good rigorous software engineering process can help you. We are going to have faults. These are going to occur when your human, your user, which are just by and large terrible people. Users are the people that break software. They create errors, meaning that they use the software incorrectly. This is an issue that I have had with Ubuntu on Windows for the longest time. If I launch it and then I click it before it loads in, it just freezes and I can't kill it, even in the task manager. So I have made a fault. We also have failures, though, where this is going to drive me nuts, so I'm going to try to kill Python here really quickly before it takes over my computer. I know that's going to be stuck. Okay. Well, hopefully that doesn't consume all my resources. All right. Failure is when we have things in our software that depart from the usual behavior. And when we say depart from behavior, either we have a knowledge of what the software is supposed to be doing over time. We have requirements, again, written out language that says this software shall do X. If we're deviating from that, then we have a failure. Maybe it's a good failure and it's actually showing us something reasonable, but it's still a departure and we need to figure out what's going on. Could be humans, could be bugs. Regardless, we like our software to do exactly what it should be doing. All right, so this is where I'm going to skip a slide. We already know that software can go wrong. We talked about Therac. There was some issues with the IRS where a whole bunch of money was lost, but really that falls into the software glitches can happen. All right. Don't know why I animated that one in. Let's talk about quality for a second. I've been talking about what is software engineering. Again, we've talked about the failures. We've even talked about some of the good things. And I keep using this term quality. Does anybody know what quality means with respect to software? And pop that into the chat to wake people up. Yeah, what it means. Pause dramatically. The rate of WTFs per minute in a code review. I like that one. That is a good one. Thank you for that. And it's accurate. Absolutely accurate. Um, the way it performs, like speed. So there are going to be, this is a very open-ended question. It wasn't a trick question. How well it can be read. Way it performs with respect to the way it is intended to perform. These are all good answers, even the cheeky one. Software quality is basically going to be a measure of how well it performs with what is expected to do. So, Mikkel, not Mickey. Basically, yeah, we're going to write software specifications, we're going to write test cases, we're going to create models of what our software should be doing. User stupidity resistance. I'm going to guess you've worked in industry before. Basically, is the software doing what it should be doing? And if what it should be doing is wrong, that's still kind of a slight against quality. Basically, your software should be doing what you tell it to be doing, and it should be doing it well. And when I say it should be doing it well, we're going to have metrics that actually tell us, is it doing well or not? Right? We're going to write requirements later on, and we're going to have ways to measure that those requirements are valid. If I have a smartphone app, I turn it on, I start playing around, and I'm clicking it and I'm clicking and I'm clicking, and it's just responding super sluggishly, right? It's not performing quickly. I, as the user, I'm going to see, well, this thing is crap. It's running very slow. We could have specifications saying, I click a button and you respond within, I don't know, a microsecond or something of that nature. Maybe that's part of our requirements. And if I'm violating that by clicking a button and it takes 5 seconds to load, then we can actually say this quality is being violated, or this requirement is being violated here. We have a quality issue. But kind of the interesting thing with quality, though, is you have different perspectives on what that means. You, as the software engineer, are going to be looking at it in terms of cold, emotionless requirements and test cases. Is your software doing what it should be doing, what you say it should be doing? Do you have basically an audit log showing it is doing this, this, and this correctly? And when I say audit log, that's like a list of test cases that are passing or failing, or you're logging metrics and you're showing it's doing this, right? That's your view. Okay, thank you. I've got this might be fun. Give me 1 second here. My headset's dying. Let's see how quickly I can break my stream. Thought I just charged this thing the other day. So yeah, we have that. Please keep working. Are we still good? Okay, I see levels. Yay, battery-powered stuff. All right, so that's your view. There's also the user view, right? Pretend I have no idea about computing. I am not technically savvy whatsoever. I start using a phone, and I pull down your app, and it doesn't work. I have no idea what your performance metrics are. I have zero expectations about it. Maybe I'm just unhappy with the user interface. I don't like how it looks. I'm going to think your quality is terrible. I'm going to write a poor review on the Play Store about it. I don't understand what's going on inside the system, right? So that's your user view. Don't always trust your users. They don't know what's best half the time, even though they're the ones buying it. We also have product view. So basically, if your product is well put together, you can basically have a good quality based on all of these kind of metrics that we'll be talking about throughout the semester. Manufacturing could be hardware related, right? We're rolling things off the line, they all meet specification. Or we could be rolling off a whole bunch of software products off a proverbial line. Are they meeting expectations? Manufacturing can be a logical task. It doesn't have to be a real world thing. Last one here is interesting too. Value-based quality can be tied to the market as well. So if you're in the app making or game making or some kind of a product environment where you're creating software for customers, quality can be tied to your value. If people are happy to pay $5 for your app, maybe it's got an extremely great level of quality and polish on it. But if people aren't willing to pay for it unless if it's discounted or on sale or 5 cents, maybe your quality's not quite there. Kind of the whole point of this little sidebar here is that quality has different perspectives. We're going to be looking at it in terms of software and documentation mainly, though. Alrighty, so good software. This is a fun term to throw around. It's going to be tied to this whole quality term that I brought up. Basically, if you're writing software, and if you want it to be good software, you need to have a very rigorous process. I am recharging my headset. You can't hear that, I don't think, or maybe you can. It's plugged in. Stop yelling at me. Can you hear that recharge headset thing through the stream out of curiosity? Or is that just in my ears? Because the lady talking to me in my headset is very angry at me. Awesome. It's like if any of you watch Futurama, the second run of Futurama, there was the wooden robot that ran on the water wheel, and every 5 seconds she was gonna die because her water wheel stopped. That's what this sounds like to me. Anyway, we're going to talk about the process for good software. There will be multiple processes. It's going to be different for every team. It might be even different for every project. And honestly, depending on your situation, it may not matter what process you follow. And when I say process, this is going to be the process of creating software from inception to delivery and maintenance later on. There's going to be a lot of very similar pieces in a process, and it's going to depend on what kind of product you're building and what your relationship with the customer is. But kind of the important thing is that you follow that process, right? If somebody comes in to audit you, make sure that you're doing what you say you're doing. This helps with like customer trust and user trust and good quality from the public side of things. They don't necessarily care what process you follow. They just want to make sure that you're doing what you say you're doing. So if I have a plan, so let's diverge into process a little bit. I am following waterfall, which is one of the processes, meaning that we're starting at this phase, we're going to this phase, and we're doing our design. We're going to this phase doing our implementation. Next phase is going to be testing, and then that phase. They don't care if I'm doing waterfall or agile or extreme programming or any of these processes. They just want to make sure, did you do this at this date? Yes or no? Okay, let me see your test reports. Let me see this. Let me see that. Did you do all that? Great. Good job. We're happy with your process. Basically, it's just a way of making sure you don't skip steps that are important when you're developing is really all that good software is. Now, along the way, we have to have our ethics. We talked about that last time. Make sure that you're making good decisions with respect to everybody in the chain. This all kind of bubbles together. But at the end of the day, as long as you do a good job, you should get a pretty decent quality product, right? So what is good software? We have a process to follow. That's step one. You're going to have, again, these different perspectives that I mentioned. You're going to have your users. They're going to, thank you, I will recharge my headset. I do this, maybe that'll help with the distraction. Um, so you're going to have users looking at your product, whatever it is. If it is a phone app, if it is a screaming goat that somebody, it's a great quality, love it. Um, is it functional? Does it work well? Do we start seeing bugs and flaws in production? Right? Users' perspective, while hard to trust them at times, is important for the public perception of your product, right? Users who are unhappy will tell other users who will tell other users who will then make your product kind of flop. That's one perspective. You also have the internal perspective. So your product designers, your maintainers, your developers, testers, everybody involved in the process will have a viewpoint as well. As much as you hate to hear this, the business people will get involved at some point, and the marketing people as well, and they will help you understand what level of quality your product has. Maybe you as the developer don't realize that the GUI that you created is absolutely god awful for everybody except programmers. You need these other perspectives to kind of rein you in. It's good. Basically, you're going to have stakeholders. And what is I've got a good example here first. Um, Point is, we want good quality software at the end of the day. And it's going to come in from these different people. It's going to come in from your internal metrics and from following your processes. Now, public perception. This is a fun one to talk about. Here's the one that we started with, right? Look at that beautiful screen. It's our nice Tesla screen. Been bringing this up multiple times. These have all been recalled because of hardware issues. The other thing too, you look at this and think of the Therac article. I can't believe that we haven't had more problems because everything is a touch screen in these cars. I don't want to like pick on Tesla too much because I like what they're doing with electric cars and all that, but man, using an interface like this while you're driving has to be distracting. Whereas you don't, before you, now I sound like old man yells at new technology, right? Um, but you have to actually focus on this if you want to do something rather than just touching a button that you know exists. Guess I have the same issue with phones without having real buttons anymore. I mean, it looks very pretty sitting still, but driving, I look at this and I think, man, there's got to be a better way to do this. Funny aside too, I had a one of my former research students, he got a Tesla and we sat in it and the roof was all glass. And I'm just thinking how well that's going to hold up to the hailstones we get in Michigan. Here's another fun one. I picked the least not safe for work image that I could find on these cyberpunk issues. But man, that's a beautiful bug that we have here. I finally looked into the bugs in Cyberpunk, and man, they are delightful. Kind of reminds me of some of the EA games that get released in the like the Elder Scrolls glitches you see. They put in a patch that added bugs. Yeah, and I saw they released one that fixed it too, right? Hopefully. All right, where are we at? So, user perception, right? You see this. Games are products. They are billion-dollar industries now, right? You see this. Okay, yeah, it's hilarious to look at, but man, how do you feel about quality when you see this from other users getting posted? You probably don't go out and run out and buy Cyberpunk if you're the kind of person who doesn't want to get into it but for the memes. Favorite is Oblivion. I never played Oblivion. I played Morrowind. That was the last Elder Scrolls game I played, which means I missed out on Skyrim too. I need to fix this. All right, so the process now. User perception's one thing. The process is another. Hey, thank you. I love the Skyrim mods, watching them at least. I think my favorite one is a toss-up between Thomas the Tank Engine as a dragon or the Macho Man Randy Savage dragon. That's great. Uh, yeah. Yeah, well, there you go. So that's a great example too, right? Not to do too much of a divergence, but you have things that get released and rushed to production, right? You would think by this point in in the industry being software, not just gaming, we're still rushing things out to market. And why are we doing this? Right? Let's take 2 seconds and talk about this because it's hilarious, but it really highlights the problem that I'm sure that more or less you are all aware of, right? You get excited about a product, it gets rushed out because people are clamoring for it on social media and they're going nuts. The project managers, the business people, the marketing people feed that into the company, and then your development team gets rushed and we start cutting corners. We start making decisions where we'll fix that in a patch. We will fix that later on, or maybe it's not going to be an issue. And these things happen time and time again. So a little glitch like this, yeah, it's hilarious. But I mean, what if this screen glitches out while you're driving? And, maybe right now they have protections that the screen doesn't do anything other than give you information. I don't know. I've never driven a Tesla. But if they tied more important systems into this later on and it crashes, what does that do to your car? Especially if it's in, semi-autonomous mode. So these things are going to keep happening, and it's because we don't follow our processes correctly. Right? This can be avoided if we follow our process and we follow our schedules. When you start rushing things and trying to cut things out and skip steps, you really get into these problems. You can almost predict, or you probably can predict, once you start seeing things get rushed to market, I guarantee you there's going to be problems on day one. Yeah, Fallout 76 is another story. Did that ever get better? I know somebody yesterday was telling me No Man's Sky's gotten a lot better since release, but I don't know that I've heard one good thing about Fallout 76. And that's from somebody who loves the Fallout franchise. All right. Um, where are we at here? Let's talk about the process and then I'll stop for the demo. No Man's Sky, yeah, heard that. I really need to pick up No Man's Sky next time it goes on sale, I think. I don't know that that's a full purchase for me, but it's maybe a kind of divergence over the summer or something. All right, so this kind of leads us into the process, which is a good thing to kind of end on here. Process we're going to go into at length. We're going to talk about the different processes that you can follow. Basically, what a process gets you is a rigorous set of steps to develop your software. Again, you can put pieces in different places. You can even parallelize things so that, maybe this team's working on task one of our process, the other team's working on task two, and they're doing it in parallel. Or it can be kind of incremental. It can be organic. You're going to have all of the same things happening, though. The process just defines when that happens and who is involved, right? And is your team more, I'm going to use the term organic again, but it's like kind of do you self-organize? Do you self-identify who is in charge? Do you have a very rigorous pecking order of who is doing what at one point? It just depends. And we're going to actually look at which process you should pick and why. And I'm going to say this probably multiple times. It doesn't matter which process you pick. There are better ones and worse ones for particular types of projects, but the key is going to be just doing a process. And one of the things your project teams are going to pick is a software process to follow. So one of the things I'll have you do is try and figure out, hey, which software process does our team like? We're going to try and follow that. Now, I'm not going to hold you to it, but it's going to kind of guide how your teams work together. And again, the ones that actually follow a process, you know, 350 teams and real world teams, they're more successful if they actually have a rigorous process. So we will stop here, and I'll put that here, stopped here, and I like to do a short divergence into GitHub for you all. Any questions from the content so far, though? So we got about 10 minutes, and this is not promising for me getting into the Windows subsystem for Linux if it's just frozen on me. Can I kill you in the task manager? Dear Bash, please get killed. Yeah, like, I don't know if anybody else has this issue, but I just cannot kill Bash. Where's the details? Yes, I want to end you. Name the process tree. No. But the divergence is not supposed to be into my computer just not working. Yeah. Oh, let's see if I can open up another one, because otherwise it's going to be problematic. Sorry, 1 second. Had a lock door to unlock. Are you going to work now? Hopefully. Hopefully. Okay, good. Good. So, your project teams are going to, once you get organized and all that, one of your first tasks is going to be to create a project proposal. One of the other tasks will be to create a project website. I mentioned we're going to be doing everything in GitHub this semester. Basically, what you have to be doing. Hey. Oh, wait. I have a kid in my room, a scam call, and a bunch of notifications popping up. It is the time of day. Alrighty, so we're going to be putting everything into GitHub. All of your artifacts, which are basically going to be like your requirements documents, already gone. It's a very busy day. Basically, all of your software models that you create, effectively everything that we've got is going to go up in GitHub. All of your documents that go up here, all of your source code, your test cases, your website code, this is all going to be pushed up to GitHub. And one other thing you're going to have to be doing is holding weekly meetings with your team. I'll get into this when we do the assignment, but basically just have a short meeting with your team every week to touch base to make sure that everybody knows what they're working on. I have a template for you to edit. So who is there? What's your team name? The date, the time. What did you talk about? What are your goals for next week, including who's going to be doing what? I will be checking these as we go to make sure that everybody is on track. But basically treat this like an actual project. Do we do homework 2 with the group? You do part 2 with the group. Yeah, you don't have that one yet. I wanted to get you homework 1. Homework 2 part 1 is the learn Git stuff. So that is learn Git's branching. Part 2 is going to be setting up the website. Actually, sorry. Part 2 is going to be 2 separate things. Part of it will be the team project site, and the other part will be personal website. So we're going to have 2. You're going to set up 2 repositories. So yeah. So this is what we've got going on, right? All right. So we have this, and I know that some of you have never seen Git before. If you are struggling with Git and GitHub, please let me know. Again, I don't have any expectations that you know Git coming into this class. If you can at least do have a basic understanding, I'll be happy. So let's say that I want to get this repository and use it for my project team. Right, so I'm going to send this all out to you with homework 2, the second part. What you're going to do with your GitHub account is you want to fork it. Right, so whoever is going to be in charge of your project team's GitHub page, there will be one person, and then you're going to add your teammates to it. Basically, you fork it to your account, and what this does is it makes basically a copy of the repository at this point in time and makes it yours now. So I took this base repository and now I have this in my account. All right, so now it's efrederick/base. Before it was, well, it's the repository name is F2020. It's obviously winter 2021, but don't know that. I guess I should be able to update this before your homework. But now it's in my account, right? So this is tied to my personal GitHub. What I can do is say, come back to me. There we go. I can do this in the terminal. You can use a tool if you want. You can use your VS Code plugin for GitHub. I don't particularly care how you interact with GitHub, as long as you're able to put things up there and work together as a team. Right, this isn't really a Git theory class. I'll be using the terminal, but just keep in mind that you can do things like download the code as a zip file. You can use GitHub Desktop. There's even the GitHub command line now, which I'm not going to set up. I'm just going to use the terminal. Everything I will be doing is in the Ubuntu realm for Git. But I can say make dir CIS350 test, and let's go in here so I don't overwrite anything. So I want to pull down this repo. So I'm going to do git clone, and here's a link to this repository that I have forked. So I'm going to clone it. What this does is it pulls down the files into a local directory on my machine. And now I have a base directory. And if I look at, again, I'm doing this in Linux, I can look at this in Explorer. I call it CIS350 test. Here's that base folder. Oops, what did I do? So this base and this base are the same thing. I see all the files from my repository now on my local computer. We'll talk about Git pretty soon and what it is in terms of a configuration manager. Basically, you have a remote repository, though, which is this web page, and you have a local repository, which is what I've just pulled down. I will make changes in my local repository, save them, push them back up to the remote, which should be up here, and then my team members could pull that down, for instance, and then everybody can be working on the latest and greatest. So since we only have a couple more minutes here, let me show you a common thing that you would do. What I like to do before I make any changes, especially when I'm working on a team, is to do a, oops, let me zoom in on this a little bit so you can see it a little bit better. So I like to do git pull, and that checks to see if there are any updates on the remote server. Nothing's changed. Let me make a change on the server. That's a good idea. So here's my README. I can click the file. You can edit it right on the web page too, by the way. So I just clicked edit. This is Team Professor Mick Professor Sin. Okay, good enough. So I changed the team name in my README file. Let's go ahead and save that. Commit is also known as saving. So just change my team name in my README file. Great. If I look at my README file on my computer, it hasn't been updated, right? So I have to do a git pull. We see that README was changed. Now when I look at it again, we see that change is now on my computer. So basically the difference is that if your remote repository has changes, usually it's good to pull those down first, because otherwise you're going to get into conflicts with different file versions and all that, and it can be quite painful. So always do a git pull. All right, so I'm happy with that. Up to date. Let's update the README again. Oops. This is my term project. It is the best one ever. And depending on how my semester goes, I might try to do one along with you too. So I have a README file. I'm going to save it. And I'm going to quit. And I'm going to refresh this page. No updates. I haven't sent it to the server. Again, you're going to get commands for this. Sorry, we are at time right now. So git commit -m updated readme readme. I didn't add it. Sorry. Git add dot git commit updated readme git push my username, my password, and then it sends my changes to this to the server. So git add, git commit, git push. Now I refresh my page. I see an update. Point is, it's a revision control system. It's going to manage your code. You're all going to be playing with this. It's not as bad as it sounds. Any questions for today since we're at time? Are we all good? You will get practice with this as well. I'm just kind of flying through the commands in the interest of time, but all good. Awesome. And what we're going to get to as well is github.io pages as well for you all. See you next week. So like you can actually set up web pages just by pushing files to GitHub. So other than that, yes, there we go. No questions. That is really loud in my ears. Thank you. Thank you for coming to the stream. Alrighty, I will see you all on Monday. Have a great weekend, and good luck with the assignment due tonight / next week. Bye, everybody. You as well. Looks like it's going to be a beautiful day.